Okay, so let's see what you guys are up to today. So there's a couple of things that you need to do. First of all, you're working on lab number 4, part 1. And as you guys recall, show you guys. So the first part is that you're going to need to calculate the water table elevation, and then you're going to plot them on this map. Once you do that, you contour the map and calculate the average hydraulic gradient using the average of at least 3 calculations. Finally, you list potential sources, 2 or 3. I think there's about 3. So how do you do this? Well, first you've got your depth to groundwater, right? Sorry, hold on. Your water table elevation is going to be calculated by the elevation of the ground surface. So let's say in the first case, it's 84.30 minus 7.02. And then whatever answer you get, it's in meters above sea level. Okay. Then what you do is once you've plotted everything, then you draw your contour map, and then you select 2 locations to get DH, and then you find the distance between them using the scale on the map. And remember, the scale is in feet. So you need to convert that to meters, or you need to convert this calculation to feet. Otherwise, you're not going to get that. I need to do it for at least three locations. And then once you get the hydraulic gradient for 3 locations, get the average. So you're looking at the average. Get or calculate the average. Okay. So that's the first part, which we worked on last week. I'm hoping you completed that. Okay. So now part 2, it's actually not too hard. So for part 2, you're going to use this equation. This equation here. K is equal to R squared ln of L over R over 2TL times L. So TL, which is going to be the most important thing that you're going to be trying to calculate, that is when the well recovers by at least 37%. So that's that time. Okay. Then length is your screen length. So what does that mean? Remember, you've got your borehole. So let me try to draw that out for you. I'll use green this time. You've installed your well. You've got a screen. So that length here, that is L, capital L. Okay. Then it's the R. R is equal to the casing radius. Casing radius. What does that mean? The radius of the well. It's usually 2 inches. Usually 2 inches. But we'll find out in this question. Could be 4 inches, could be 6 inches. And then again, you have to convert it to the right unit. And then the large R, so this is R, small r, it's the casing radius, and then this is the large R, that's the borehole radius. And that's usually around 6 inches or 8 inches. Okay, so this is where it gets interesting. Any questions about this? But this information should be given to you in the lab. But this is what all of this means. And The equation is posted for you. And this will give you, so this is the hydraulic conductivity. And this is important that you guys understand this for a few main reasons. Number one, this is in your test. This is going to help you in your test calculation. The final, I believe some of these things will help you. Number two, if you join an engineering or consulting firm, they use this type of these types of calculations. So it's good for you if you get into consulting, especially when it's related to water balances, development projects, hydrogeology. Okay, so now that we talked about that, so you're given data. And what does this data mean? So this is kind of, it's important for you to understand what this means. So basically what they've got is they've got a well. Let's just plot out the well. They've got a well. Screen. This is probably your typical static water level. Remember, that's when there's no pumping. But right now, the water has been lowered so that you've got your dynamic water level. Okay. And according to this, it says that the pump is shut off at, let's see what this is, depth to water. Let's take a look at this. The depth to water when the pump is shut down is 10.59. So let's write that down. The depth to water when the pump is shut down, pump shut, this is going to be important. So the depth to water at that point is 10.59 feet. And the time is 13:14 p.m. So 1:14 p.m. And oops. And when you keep looking at this, it says that its well recovery is 90%. So when it's 8.60 feet at 17:14, that's 90% well recovery. So based on that, can you determine? So based on that, can you determine at what time is it, 37% well recovery? Right? I mean, you can say it was 5 minutes to 90%. So you can use this type of an estimate, or 90% was achieved at 5 minutes. 1% would be achieved at 5/90. So 37% would be achieved at 5/90 times 37. That'll give you the minutes. Or you can do a mini graph. So different people have different approaches, right? So once you've determined that, that's going to be your TL. And what you're going to do is you're going to then create an Excel spreadsheet where you're going to calculate. So you're going to calculate using the screen length. Remember what the screen length is? L, the diameter is 2 inches, converted to meters. The diameter of the borehole is 6 inches, converted to meters. And you have now determined the time, 37%. I believe that's in minutes. Hold on. Give me a second. So you're going to determine you're going to use the lag time. Let's see, what's the lag time that you're going to use? Now you're going to use it in minutes, okay? That would be TL. And then what you do is you've calculated K. You're going to assume that P1, which is the pumping well that we've got, is going to use the conductivity that you calculated with the hydraulic gradient that you calculated in part 1 to determine. What are you going to determine? What you're going to determine is how long it would take for your plume to get from this gas station to the lake. Because you've calculated K. So you're basically going to use everything that you calculated. So from last week, you will have calculated the average hydraulic gradient from last week, right? You have it from part 1. From part 2, you're going to get K from part 2. So velocity is equal to K dH by dL. So once you have the velocity, after combining part 1 and 2, determine the distance from your map. It's in feet, so convert it to meters. So remember, once you get that, velocity is equal to distance over time. So time will be distance over velocity, which is your final answer. All right. So let's get started on that today. Look at this here.
Oh, a question.
Yes.
Yes, that T in the velocity equation, is it the same thing as capital T?
TL, yeah.
That's TLT.
Hold on. What are you talking about? This has nothing to do with TL. That's a different
Oh,
equation.
okay.
Like when you studied physics as a 12-year-old or 13-year-old, do you remember the velocity is equal to distance over time?
Yeah.
So that's what you're going to use. Once you calculate the velocity using Darcy's equation, you should be able to find out how long it would take for that plume to get from the gas station to the lake.
Okay. Okay. So the capital T is for the recovery rate. How
Yeah,
long it will take to recover a certain percentage of the water?
37%
Okay.
in minutes.
Okay.
Okay. But
Yeah.
don't worry. Every time you have a question at each step, just start step by step. Number 1, did you finish part 1?
Yes, I'm done with part 1.
Okay. Did you get an average hydraulic gradient?
No, I haven't calculated that aspect,
Okay,
but
then
I've
just
done the,
focus on that right now.
yeah.
Okay.
Yeah.
Because this is it. There's no more assignments for this semester. When is this lab due? So you have a few weeks to finish this. Okay. So this lab is not due till the 13th of April. But if you do what I urge you not to do and leave everything till the last minute, well, you're going to have problems. Just because you have many weeks to do this does not mean you leave it till the last minute. If you do, well, good luck. Because what's going to happen is next week during the lab class, you're going for the waste plant tour, right? And we're switching the lab class with Andrew. Sorry, we're switching uh, so Andrew's going to take your VS360 and I am going to, well, if he needs to, he said he's going to think about it if he needs to. If you're well enough ahead, he might just leave that as a study on your own.
Professor,
Yes.
I think he mentioned that he might take one of the VS
Okay, did
classes.
he? Well, it's only one class, it's three hours, so he'll have to determine. But you'll have to talk to him about that. I still have
Mm-hmm.
to get the directions for for April the 2nd. I haven't gotten them yet. I'm gonna try to call him.
Mm-hmm.
And what I'm trying to say is don't stress out. Just
Yes,
focus on
Professor.
each step.
Mm-hmm.
So next week, there's no lab class for this.
Okay.
Just work
Noted.
on this. During the lab class, you'll be going to the organic waste tour,
Yes,
which
sir.
also replaces your VS360. There's no VS360 next week either. I'll give you this in detail in an email.
Okay, Professor. Thank you.
And then on the 9th, we just go and we practice at a monitoring well. Just learn about the discipline, the etiquette, and just see what a well looks like, how you purge, how you sample. There's nothing going on. That's on the 9th. And then you basically finish off. Now, the good news is this week as well, um, you have this class and you have Friday. So you can work on any of the items because you've done a lot of good work and we're far ahead enough in this course. So you've got lab number 4, which we've talked about today. And feel free to bother me again and again because I want you to get this done right. The only thing that annoys me is when people don't attend the class and then they want me to go back and repeat myself, which I guess if you're sick, I will do for sure. But if you don't attend class, then it's kind of your responsibility to catch up. So then there's the term report and the AOC assignment. Now, many of you have completed the AOC assignment, which is wonderful. So there's this Friday a work session. I'm expecting you to attend to finish this stuff on Friday. Is that clear? Did I say that in my weekly email, or am I being a hypocrite? Can somebody confirm if this is what they understood for this week that you're going to work on that? This is not easy stuff. This is new for you, so you want to have your full attention, and I don't want to be focusing on new stuff when this is important. Yeah.
Professor,
Yes.
I understand, but could I email you something later?
Why don't you just ask now?
No, basically, I was just gonna ask you if you could email me the recording of this class,
Why?
just to clarify
No,
some things
no, 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 no,
later.
no. Clarify by asking me questions.
No, because like I
No, I
want
don't want to. I
to
don't want to encourage
review.
people asking for recordings because then people don't attend live.
I mean, that's very true. But
Yeah,
like
like
I'm
like
here.
this is if it's an asynchronous class, that's different.
Uh-huh.
But for a synchronous class, now in your case, the reason why I'm
Mm,
going to share the recording with you is because you attended the
mm-hmm.
class, so you
Thank you,
earned the right
Professor.
to get the recording afterwards.
Mm-hmm.
But
Thank
if you
you.
didn't attend this class
Then I'm
and you
done.
said, then this is what would happen.
Professor. But
But
thank you,
if you
Professor.
attend the class, I'll share it with you.
Thank you.
Okay. Does that make sense? Because then you can use that recording. Now, there's no lecture on Friday. What are you going to do on Friday? Oh, one other thing. So you do have some homework though. Watching the webinar on the remediation case study, that should be helpful to you, especially if you want to get into remediation and consulting contaminant sites. But other than that, I'm going to stop the recording now because that is the end of the information. But yeah, if you don't mind asking questions, please do, because then I can repeat myself and everybody gets the benefit. But if you prefer to wait till you watch the recording and then you ask the question, then there might be a delay in the answering. Of course, not this week. This week, on Friday, you have the whole session. You know why we have this extra session? Partly it's also because we ended up not having Easter during the semester. It's at the end of the semester. So you've lucked out that way as well. Stop the recording.